Okay, so we're dealing with terms, like terms, and coefficients. Okay? All a coefficient is a number in front of a variable. Okay? So the coefficient in this problem is 2. Understand?
What's the first number?
It's always the first number, usually in front of a letter, in front of a variable. Okay? Terms. That's anything before an operation. Plus, minus, multiply, divide. Okay? So even though these are numbers, that's a term, that's a term, that's a term. Okay? That's a term, that's a term. An operation separates a term. Okay? Like terms means they're like each other, you can combine them. So that's this right here. Are these terms like each other? No, they're not. Even though they have the same variable, they have to be the same power to be able to add, subtract, multiply them, whatever. Okay? So looking at this first example, we're not necessarily solving problems. What we're doing is we're reorganizing problems. So ultimately, it's like we could do it in our head. So this one, 4 times 9 times 25. We take 4 times 25, put it in parentheses, which is 100, times 9, which is 900. We didn't need a calculator to do that. Okay? Addition. 75 and 25. Pretty much everyone knows that in here, right? You have 75 cents and 25 cents. Do you have a dollar? Yeah. So then bring down 48. 100 plus 48, 148. I got asked this problem in multiple classes. Well, how do I do this one? All you're doing is reorganizing this problem to make it easier. So 100 plus 3 is the same thing as 103, right? So from here we're doing distributive property. 15 times 100, 1500. 15 times 3, 45. Now we add it together.
Why did you do 15 times 3? I thought it was 100 plus 3.
What's 15 times 100? Okay, what's 15 times 3? By us breaking this up, 100 plus 3, it's the same exact problem, but we can do this in our head without a calculator. Okay? Make sense? So what about this? What about this one right here?
You do 1,000 plus 2.
Very good. 1,000 plus 2. Yep. What about this one?
50 plus 2.
Very good. Yep, that's it. Okay. Anytime the numbers are odd, add 1 to it. Okay? So 6 times 19, 6 times 20, that's easy. 6 times 2 is 12. We add a 0, right? And then 6 times negative 1, negative 6. Solve the problem. Are these like each other?
No.
They are.
Why?
12. Well, there's x. There's no power. X, no power. Same variable. We can add these together. So 30 plus 12 is 42. Are these like each other?
No.
They're not, because this is the power of 3, and this is the power of 2. This problem is done. We can't do anything to simplify this problem.
So
This
you
one's...
wouldn't do 3 to the 5? So you wouldn't do 9 plus 4?
Nope. We can't do anything with this because we don't know what that variable is, and that variable will impact the problem any which way we see it.
So the next one over is already done?
This one is not done because this is a y to the second power and y to the second power. They're the same. What's in front of a variable that we can't see in algebra? A 1. So this is 6.8 minus 1. So basically that's just 6 minus 1. Write the rest of the problem. Okay? But those are like each other. If it's a minus a variable, it always has a value of 1. What about this one right here? Are the variables to the same power? They're not. We're done. There's nothing else we can do with this one. That n and that n2 are not like each other, even though they're the same variable. Okay, when we have parentheses, we solve inside the parentheses first, but we can't solve this because we have an x in here. Okay? So the way we do this is 2 times x, 2x, 2 times 6, 12. We multiply everything that's inside the parentheses. Bring down the 3x. Now we can combine our x's. 3 and 2 is 5. Bring down the 12. We're done with the problem. Now I'll tell you, technically, we can solve that. But we're not there right now. Okay, we discussed this. This is just like your handout, or your worksheet. When you have area of something, this 40x, this would be 40x as well. This is 30x, this would be 30x as well. So this would be you like walking the school and counting your steps all the way around, right? If you know this side, this side, this side, this side, you can figure out what the area is. So we take this, 40, we put another 40 for this side, 30, another 30 for this side, add these together. So 40 plus 40, 30 plus 30 is 140, x. We can combine them, they're all x. Okay? Any questions? This one's pretty easy. Probably the easiest one we're going to have. Because then we go into functions. We start getting into, we covered all the basics, and now we're getting into algebra. So we talked about these two, right? Can we combine these two?
Yeah.
We can. Now I have a question. Positive and a negative, right? What's the answer? Is this one positive or negative?
Not a positive.
Very good. Did everyone hear that?
No.
When you're looking at an addition or subtraction problem, you ask yourself which one is larger. Whichever one is larger retains the symbol. So you're absolutely correct. That 35 is larger than the 15, so us subtracting out, we know that the answer is positive. What if it were the other way around, and this was plus and this was minus?
Then it would be negative.
Right, because the negative is now larger. So looking at a problem, you want to ask, first thing you want to ask yourself, which one's larger? The larger one retains the symbol. Okay?
But sometimes why when I put it in the calculator, it comes out like.
That's why I tell you this.
When
Because
do you know you have to do that?
have to do, oh, whether it's large,
Like, how do you know when?
that's an excellent question. Adding and subtracting. Okay? We know that this is subtracting. Okay? So adding and subtracting, whether it's when it's positive and negatives, it's whichever one's larger. Now what if it's negative and negative? No. That's like you borrowed, if it's subtraction, you borrowed $10 and you borrowed another $10. How much you owe?
$20.
Right. Because it's negative 10.
But you said negative times a negative is a positive.
Correct. We're talking about adding and subtracting. When you're negative 10 and you're negative 10, it's negative 20. It's increasing the
That's
negatives.
what I meant, like, how do you know when?
Oh, when it's subtraction or addition. When it comes to multiplication, then that rule applies. Or division. Multiplying, dividing.
So those parentheses right there, then it would have been like.
There, yep, it would have been a negative. Because it would have positive times a negative. That's a good question. Okay, what about this? What about this one? Are these like each other? They are like each other. They're both to the variable of a. That one's kind of stretched a little bit. Is this positive or negative? Positive. Very good. What about this one right here? What's in front of that R we can't see?
1.
Okay, what I just tell you about negatives? Adding and subtracting. What's the answer to this? Because we're not multiplying, right? This is saying 8R subtracted by R. What's in front of that R we can't see? Okay, so if you borrowed $8 and you borrowed 1, how much do you owe now? Very good. So negatives when it comes to subtraction are just increasing. Don't be the one. What do I mean by that?
Don't be the one.
Right? Didn't I tell you the answer to number 5? Yeah, several of you will miss it. Okay, this one's just like the example here. We multiply 2 times x, 2x, 2 times 6, 12, bring down the 3. This problem's identical. Multiply the 5 times the x, the 5 times the 3, combine your x's, rewrite the problem. This one, what do I do with that r?
Take it away. Put it away.
Does it matter?
No.
It doesn't. You want to add your x's, they're like each other, leave the r alone, plus r when it's all said and done. Now I'll tell you, our brains play tricks on us. Same with this one right here. And the reason being is you're so used to seeing x's and y's. It could be any letter. It could be w, it could be q, it could be any letter. Okay? You're looking for letters and combining them as long as they have the same power. Okay? Alright, let me explain what it is that you should have done at this point. I know some of you missed on Friday. You have your notes to get done, you have your vocabulary to get done. When you flip over the worksheet or over the notes, you have the worksheet. You want to finish the worksheet, okay? You have this due now, and you have on page 49, 26 through 43. All these lessons don't take very long to do. They're fairly easy. We just need to get the practice down and move on, okay? All right, so now I should see you finishing your notes, okay? So I should see the pencil moving. Get this down, right? Get this done. You're turning this in now. Then you can take this and finish it. The worksheet's on the back side. If you need to, take a picture of the book on page 49. You're doing 26 through 43, okay? So this and tomorrow's lecture, we're getting into functions, is what the test is going to be on Thursday. Okay? Okay, make it happen. You want to start on that? Do now. And remember, I gave several of you the answers to it.